Hi guys, so today we're going to look at some more conic sections. So you've actually already seen two of the conic sections already. One of them you did back in geometry, the other one we did earlier this year and we looked at parabolas. So we're just going to review those first two before we move on to the new stuff. So to review, the first one, the locus of all points equidistant from a fixed line and a fixed point is a parabola. And the locus of all points is really just saying all of the points that are equidistant from those two things. That line was called the directrix, and the point was called the focus. Then the other one, the locus of all points on a plane that are a certain difference from a central point, that is a circle. Now, if you don't remember standard form of a circle, x minus h squared plus y minus k squared equals r squared. So on this first one, that is a circle, but it's not in standard form. So in order to get that circle in standard form, we need to complete the square. So I'm going to rearrange this. I'm going to put the x's together and leave a blank. I'm going to put the y's together and leave a blank. And then I'm going to move the 45 to the other side. So to figure out the number that goes in the blank, you take the b value, you divide it by 2. I add it to both sides. The orange one, b value divided by 2, add it to the other side. And then I can factor those trinomials. So the 3 blue terms are going to factor into x minus 5 squared. The 3 orange terms are going to factor into y minus 6 squared. And then the other side of the equation, that's going to simplify to 16. So then if I want to graph this circle, the center is 5, 6, and the radius is 4. So I would go to 5, 6. And then I'm going to move basically 4 in each direction from that point. And I have my circle. All right, the next one, that's a parabola. This is a parabola that's going to open left. We know it opens left because it's x equals and y squared, and because it's negative. The p-value here is 3. My vertex is going to have an x-coordinate of 3 and a y-coordinate of 1. So remember, the y-coordinate is with the y there. To find the focus, remember, let's go ahead and plot this. There's my vertex. If it opens left, the focus will be left. The distance I'm going to move is 3 because that's my p-value. The directrix is that line. It's going to be on the outside of the parabola. So x equals 6 is my directrix. Then I need 2 more points on my graph. So if p is 3, then I'm going to move double that basically in both directions from the focus. So I'll move 6 up and 6 down. Because the total distance of that lattice rectum is 4p. All right, we're just going to do 2 more where we're writing the equations. So this one's a circle. It gives me the diameter endpoints. Well, in order to write the equation of a circle, I need the center and I need the radius. So to find the center, I need to know what's the midpoint of those 2 points. Well, for the x's, halfway between 1 and negative 5 is negative 2. Halfway between 4 and 8 is 6. To find the radius, I need to know how far away the center is from one of those endpoints. It doesn't matter which one you use. I'm going to use 1, 4. So I need to know that distance. If you don't remember the distance formula, that's okay. You can just use Pythagorean theorem. So this side-to-side distance is 3. This up and down distance is 2. So the radius there would be the square root of 3 squared plus 2 squared, which is the square root of 13. So this would be x plus 2 squared plus y minus 6 squared equals 13. And then our parabola, it tells us the focus and the directrix. So there's y equals 8, and there's 3, 2. I know the vertex is going to be halfway in between those two things. So halfway in between those would be at 3, 5. Because this is a horizontal line for my directrix and the focus is below, it's going to open down. So it's going to be y equals, it's going to be negative The p-value is the distance between those two. That's a distance of 3. And that would be the equation of my problem. All right, so now we're going to move on to the new ones. We're going to look at an ellipse. So an ellipse is the set of all points where the sum of the distances from any point on the ellipse to two fixed points, called foci, is constant. Foci is just the plural of focus. So one focus, two foci. So what this is saying is that the sum of those distances is going to be constant. And we looked at some examples in class, and there's some links on Schoology, but I'm going to go ahead and show you guys one of them. All right, so this is an example of an ellipse. The point right here in red, that is a point that's on the ellipse, and it's showing you this orange line is the distance to this focus. This purple line is the distance to this focus. Those distances are actually marked right here. So this number here is the length of the purple line. This number here is the length of the orange line. So if you look down here at the bottom, I'm not sure if you guys can see the mouse on this or not, you'll notice that's the total distance of those two numbers combined. And as we move this point around the graph, you'll notice that total distance stays the same. So that point can go around. Okay, right now it's at a different point. Those distances are different, but the total distance is still 10. So that is all of the points. So those total distances, again, are still staying the same. So again, there's that video we saw in class as well that shows you kind of drawing an ellipse this way where you have that string that's the same total length as it goes around. Okay, so going back to what we had on here, we're going to look at some examples. You can see right here is you can have either a horizontal ellipse or a vertical ellipse. The standard form for both equations is there. You'll notice they're very similar. Both of these equations, first of all, are equal to 1, which is a little bit different than what we've seen so far. The only difference you'll notice is the a and the b value. And when it comes to actually graphing this, it's not necessarily important to know which one's A and which one's B. What's important to know when graphing is that A, whatever's under the X, that's the distance you're going to move horizontally. Whatever's under the Y, that's the distance you're going to move vertically. The reason they flip between A and B is because A has to be the larger number. Right? A has to be the larger number. And the reason that matters is for whenever we find this C value. So this C value is how we determine where the foci are, okay, or basically your focus is. And that's determined from that equation, and in that equation, it's a squared minus b squared. So the larger number there has to go first. All right, so on this graph, the center is HK, just like it has been. So then on this graph, basically A is kind of like a horizontal radius and B is kind of like a vertical radius. So the distance from the center to this endpoint horizontally, that's going to be A. The distance from the center to this point vertically, that's going to be B. C is the distance to the focus, and the focus is going to be somewhere inside here like this. The focus is always going to fall on the major axis, which is the larger one. And the major axis is basically this entire length right here. So it's 2 times A. The minor axis would be this whole length right there, which would be 2 times B. Some other vocab on here. The endpoints of the major axis are both the vertices. The endpoints of the minor axis are the co-vertices. And then on this graph, since the foci fall on the major axis, you need to look at those in relation to the center. So in relation to the center, the y-coordinate is the same. What's changing is the x-coordinate. So we're taking the x-coordinate of the center, and we're going to add and subtract c in order to find where the foci are. So there's one focus, and there's the other. All right, so we'll look at this one. Again, same thing, but you'll notice the larger number is under the y. When the larger number is under the y, it's going to be a vertical ellipse because, again, this distance here now will be A because it's the distance that's under the y. It's the larger number, too, in this case. B would be like this radius right here. C is going to fall on the major axis. So that length is C. So that's a focus. And that's a focus. So this time for my focus, I'm not changing the x-coordinate of the center, I'm changing the y-coordinate of the center. So to graph these, the vertex would be here and here. The co-vertex would be these ones, because the co-vertex falls on the minor axis. All right, so if you want to see some more examples of these, there's another link on Schoology, and we'll look at that real quick. All right, so this one is just showing you what happens when you move all those different values. So H moves your center, K moves your center. The smaller B is, in this case, B is always listed under the Y. And that changes your height. And again, the value of B is how far the distance is vertically from the center to the, in this case, co-vertex. A is going to be the distance horizontally from the vertex to the center. And if I change that, it gets larger or smaller. When the number under the Y is bigger, it becomes a vertical ellipse and it is taller vertically. So the other thing on here it shows you is what the foci look like. So on this one, the A value has to be larger in order to actually see these foci. But you'll notice, let's go ahead and make this a little bit smaller here. So as this gets narrower, you'll notice the foci are getting closer to the edge. As this ellipse gets wider, those foci are coming closer to the center. And if it were to be exactly there, well, then it would be a circle and wouldn't be an ellipse at all. So those two values will never be the same because, again, it would create a circle and not an ellipse. If it's vertical, the foci are going to fall on that vertical axis. And again, the narrower it is, the closer they get to the edge. If it's wider, those foci are closer together. So we're going to go ahead and actually graph some of these now. So I know it's a lot of vocab, but once you get in the habit of actually graphing these, they're actually really not that bad. So the first thing we're going to find here is our center. Well, the center is going to be -3, 1. Because the value under the x is larger, this is going to be a horizontal ellipse. So we'll plot our center. And then I'm going to go ahead and graph it actually before I find any more of this information, because graphing it's really not that hard. Because 25 is under the x, the square root of 25 is how far I'm going to move left and right from my center. So I'm going to go right 5 and left 5. Vertically, since 9 is under the y, I'm going to go the square root of that up, so up 3 and down 3. And I have my ellipse. So from here, I can find the rest of these values. Well, A is what we just used. That's 5. That's 3. In order to determine C, I need to use my other equation. So C squared is equal to A squared plus B squared. Sorry, A squared minus B squared. So in this case, I don't know C squared. A squared is the larger squared value. So C squared is 16, which means that C is 4. And that's what we're going to use to determine where our foci are. The major axis is this length here. That's going to be a length of 10. Minor axis is that total distance, which is 6. The vertices are the two that are on those ends because those are on the major axis. So that's -8, 1 and 2, 1. Co-vertices are -3, 4 and -3, -2. So the foci are going to be on the major axis, which means from the center, I need to move a distance of c. So I'll move 4 away from the center to get my foci. So one of those is going to be at -3 plus 4, and the other one is at -3 minus 4. Domain left to right, this graph goes from -8 to 2. It does touch both those values, so that's going to be in brackets. Range, the lowest y value is -2, the highest y value is 4. So again, that also goes in brackets. All right, on B, very similar, but it's not in standard form yet. So standard form, it has to equal 1. So the first thing I'm going to do is I'm going to move 81 to the other side. Then to make it equal 1, I'm going to divide everything by 81. And that's going to give me my standard form equation. If I simplify 9 over 81, that's over 9. And there's my equation. The center here is 1, negative 4. Since the value under the y is larger, this is going to be vertical. And we'll go ahead and graph it. So 1, negative 4 is my center. I'm going to go 3 left and 3 right. I'm going to go 9 up and 9 down. And that's going to take us off the graph. But I get my ellipse. The A value on this one actually was 9 because, again, it has to be the larger one. The B was 3. So to find my C value, C squared is A squared minus B squared. That means that C squared is going to be 81 minus 9, which is 72. So C is the square root of 72, which is 6 root 2. Major axis in this case is the vertical one, so that's 18. Minor axis is horizontal, which is 6. Vertices are up and down, so 1, 5, and 1, negative 13. Covertices, negative 2, negative 4, and 4, negative 4. Foci, we are changing the y-coordinate, not the x-coordinate. So my x-coordinate is 1. To get the y-coordinate, I'm going to add and subtract the c value, so negative 4 plus or minus 6 root 2. It doesn't really get very pretty. We're just going to leave it in that irrational form. All right, domain and range. Farthest left that this graph goes is negative 2 to 4. Bottom to top, negative 13 to 5. Now, if you wanted to graph the foci here, what you would need to do in order to graph your foci is you would need to determine where is 6 root 2, or where is that in relation basically to my center. Well, I don't know exactly the value of 6 root 2. What I do know, c squared is 72. Well, I know 72 is less than 81, and 72 is greater than 64. And those are perfect squares. So if 72 is in between those two, well then c is going to be in between the square root of those numbers. So I don't know the value of c, but I know it's somewhere between 8 and 9. So from that center point, if I went about 8 away and about 8 in the other direction, that would help me find where my focus was. All right, so the hardest part algebraically on these is going to be completing the square. And it's going to be very similar to what we did with circles, except these are going to have coefficients. So again, first thing I'm going to do here is I'm going to rewrite it. I'm going to put my x's together. And then I need to factor out whatever's in front of that x squared term. So 4 would get factored out, and I'll leave a blank. Then out of the next two, I need to factor out the 9. I left off a y up there, sorry. Okay, the number in the first blank, negative 12 divided by 2 squared is 36. But I didn't actually add 36 to this equation. I added 36 times 4 to this equation, which is 144. And the green spot, 8 divided by 2 squared is going to be 16. And again, I didn't really add 16. I really added 9 times 16, which is also 144. So the blue part can factor now. That's going to factor into x minus 6 squared. The green part's going to factor into y plus 4 squared. The right side of the equation is going to simplify to 144. Divide everything by 144. And then we can simplify those fractions. And these are actually pretty easy to simplify because we already did it above. So x minus 6 squared over 36. Y plus 4 squared over 16 is equal to 1. So now if I want to sketch my graph, the center would be 6, negative 4. Horizontally, I would move a distance of 6. Vertically, I would move a distance of 4. And I have my ellipse. Now the last thing it tells me to find are the foci. So in order to find the foci, I need that c value. C squared is a squared minus b squared. So that's going to be 36 minus 16. So C is the square root of 20, which is 2 root 5. Since this is a horizontal ellipse, we're going to change the x coordinate of the center. So I'm going to go from do 6 plus or minus 2 root 5, comma, what was my negative 4. If you had to graph this, I need to figure out about where 2 root 5 is. Well, 20 is in between 25 and 16, so this is going to be somewhere in between 4 and 5. So I would move about 4.5 away. And that can give you about where the focus is. All right, so the last thing we're going to do is we're going to write equations of ellipses from some information. So depending on the information you're given, we'll need to determine basically the center and then our A and our B values. Well, in this one, it doesn't give us the center, but it's actually pretty easy to determine the center based on what it gives us. So if a vertex is at 6, 0, and 0, 4, I don't know the center, but I do know this is the minor and this is the major axis, and the center is where those two things intersect. So in this case, my center has to be 0, 0. Once I know my center, this is going to be x squared over something plus y squared over something equals 1. Below the x, that is how far I moved horizontally from the center to that vertex. That number squared is 36. Vertically, I moved a distance of 4. 4 squared is 16. All right, on B, it gives us the center. It also gives us a co-vertex and a focus. So there's a co-vertex and there's a focus. So I know that this is going to be a vertical ellipse because of where the focus is and also because of where the co-vertex is. So x squared over something plus y squared over something equals 1. I can go ahead and determine at least this horizontal distance because going to the co-vertex was 5. So this is 25. So vertically, I don't know how far I'm going up there. I only know the distance to the foci. Well, c squared is a squared minus b squared. So that means that 9 is equal to, in this case, I don't know a. Because again, I know the co-vertex. I don't know the vertex. I don't know the larger one. So a squared is what we're looking for. B squared in this case is 25. So this is a case where it does matter which one is A and which one is B. So then from this point then, I can solve for A squared. I get that A squared is 34. I don't need to worry about square rooting it because it's squared in my equation. All right, on this next one, we need to determine our center. So vertices are at 2, 1 and negative 6, 1. So the center is going to be halfway in between those two things. Well, halfway in between them would be negative 2, 1. The minor axis has a total length of 4, which means if the vertices are on these endpoints, the minor axis has to be going up and down. So if the total length is 4, I'm going up 2 and down 2 to get to those endpoints. So my equation then would be x plus 2 squared, y minus 1 squared, it's going to equal 1. Horizontally, the distance that I'm moving to get to that endpoint, I moved a distance of 4, so 4 squared is 16. Vertically, I moved a distance of 2, and 2 squared is 4. All right, on D, it tells us the foci and the major axis length, so I do not know any information about the minor axis. I know since my foci, though, are located here and here, I know the center is going to be halfway in between them at 0, 0. I also know if the major axis has a length of 8, that means I'm moving 4 in each direction from the center, so that means that my A value is 4. Which means since it's vertical, 16 is going to go under the y squared. All right, so then the last thing I need to do is I need to solve algebraically in order to get my missing value. In this case, I know the major axis length, so I know the a squared value. What I don't know is the b squared value. Since the distance was 2 to get to the focus, c squared it would be 4. So b squared is 12. And that's the equation of my ellipse. All right, so next class we're going to look at hyperbolas, which are going to be pretty similar, similar process just with a few changes.